I finished my video and I am starting to second video about this subject because we have to know also integration by partial fractions, and the operations are long here. That's why I'm starting to second one here in another video, not to be so boring about the integrating partial fractions. Here x plus 1 we have over x cubed minus 1, and I'm going to use this form because when I factorize x cubed minus 1, it's going to be equal to x minus 1 times x squared plus x plus 1 it should be, and that we cannot factorize the second one. So integral of x plus 1 over x cubed minus 1 dx, it must be equal to integral x plus 1 all over x minus 1 times x squared plus x plus 1 dx. So I'm going to separate this one. It was written like this here. For this one I'm talking, it was written like this: a over ax plus b and plus bx plus c over ax cx squared dx plus e is going to be. Then here I'm going to apply the partial fraction method, and it's going to be in this form. Before the integral, let me solve the partial fraction part. Integral x plus 1, I said again integral, but x minus 1, I'm going to use partial fraction method. X squared plus x plus 1, it's going to be equal to a over x minus 1 plus bx plus c over x squared plus x minus plus 1, sorry. And the denominators, they are not same. First I need to make the denominators same. This is polynomial equality because all the terms are polynomials. That's why denominators must be same than numerators. And it's equal to x plus 1 over here x plus 1 over x minus 1 times x squared plus x plus 1 is, when you write here x squared plus x plus 1 and here x minus 1 up, it's going to be a times a x squared plus x plus 1 plus bx plus c times x minus 1. X minus 1 it's going to be, and down x minus 1 times x squared plus x plus 1 it must be. X minus 1 and x minus 1 we simplify. X squared plus 1, x squared plus x plus 1 we simplify the denominators because same denominators. And what is written up, it's going to be these are going to be equal also. A plus x plus 1 is equal to ax squared plus ax plus a plus here bx squared minus bx plus cx and minus c is going to be our solution. Firstly, I have to collect the common variable terms together, like x plus 1 is equal to a plus b x squared, and ax and bx we have, and minus bx and plus cx, so plus a minus b plus c x it should be here, and the last one is a minus c. It's going to be here. I understand this one. Firstly, a plus b, they are equal to 0 because the x squared term here on the right side we have, on the left side we don't have an x squared. That's why a plus b must be equal to 0. The second one, a minus b plus c, it's equal to 1 because here it's written 1. a minus b plus c is equal to 1, and the last one, a minus c is equal to 1. It's going to be. Now when I add them, I see that these terms, they are going to be here similar to each other. So when you add them side by side directly, they are going to give us the only one value here. That's going to be, I think it's here, a value. It's going to be 3a is equal to minus b we simplified, and c and minus c we simplified. So on the other side we have 2. A is equal to 2 over 3. If a is equal to 2 over 3, easily I can find the b. B is equal to, here it's going to be equal to, b is going to be equal to minus 2 over 3, because a plus b is equal to 0. And the last one, a minus c is equal to 1. So 2 over 3 minus c is equal to 1. Minus c is equal to 1 minus 2 over 3. Minus c is equal to 1 over 3. And here it's going to be c is equal to minus 1 over 3. It must be. I'm going to use this one in the questions here. It's going to be equal to integral x plus 1 over x minus 1 times x squared plus x plus 1 dx is going to be equal to integral minus is equal to 2 over 3 over x minus 1 plus integral bx plus c. It's going to be equal to minus 1 over 3 minus 2 over 3 minus 2 over 3 x plus, actually minus 1 over 3 all over x squared plus x plus 1 dx is going to be. Okay, then if it is in that form, if it is in that form, this is going to be 2 over 3 integral 1 over x minus 1. This is the x plus b x 1 over x plus bx form. So this is going to be an absolute value of u plus here integral. If I get 1 over 3 parenthesis minus 1 over 3 parenthesis minus 1 over 3 times integral 2x plus 1 over x squared plus x plus 1 dx. And here I'm going to use the substitution method again for the second one, and I'm going to write like this: u is equal to x squared, plus x plus 1, du is equal to 2x plus 1 dx. So instead of 2x plus 1 dx, I'm going to apply du. So it's going to be like this: integral, this is going to be equal to this expression 2 over 3 1 over x minus 1 integral. It's going to be ln absolute value of x minus 1, and minus 1 over 3 I got before, that's why it's going to be minus 1 over 3 integral 2x plus 1 dx is equal to du over u, which is equal to ln absolute value of u plus c. So it's going to be equal to 2 over 3 integral ln x minus 1 minus 1 over 3 ln absolute value of u plus c, it must be. And this is the last step: 2 over 3 ln absolute value of x minus 1 and minus 1 over 3 ln absolute value of x minus 1. Instead of u, we have to write x squared plus x plus 1 plus c.